For the past month, I've been using an AI coding agent almost every single day to build my projects, and it hit me, why am I renting AI from the cloud when I could run all of it myself right here at home? So I decided to build my own local AI server, and it's actually going to be two machines. First, the star of the show, the RTX 5090. 32 gigabytes of memory and over 21,000 cores. This is the card that's going to run my heaviest local AI models. Honestly, just holding the box feels a little unreal. To feed a card like that, you need serious power. The Corsair HX1500i, 1500 watts, platinum rated, and way bigger than my old unit. The build quality on this thing is honestly insane. And here's the rest of the haul, all laid out together. The memory, the processors, the boards, the network gear, and a pile of accessories. Months of planning, finally sitting on the table. There's even a Netgear gigabit switch in the mix. This is going to be the backbone of the whole setup, wiring every machine together so they can talk to each other instantly. So let's start with the first machine. This one began life as my gaming PC, built around a Ryzen 9700X. But I'm completely changing its purpose. From now on, it runs local AI, so anyone in my community can come and try it out for themselves. The plan is simple: keep the processor and the memory, but give it a real upgrade. So the first job is to rip out the old power supply. This thing has been dying for a while, rattling and screaming under any real load. Out with the old, in with the new. The Corsair drops into place, and finally I've got clean, stable power for the 5090 and everything around it. Now comes the part every builder secretly dreads: the cables, CPU power, the 24-pin. All of it has to be routed and locked in properly. I even bought a dedicated 12-pin cable just for the 5090. With a card pulling this kind of power, this is the last place you ever want to cut corners. Then it's all about routing, tucking every single wire behind the motherboard tray, so the airflow stays clean and the whole build just looks the part. Locking the PCIe power into the graphics card and double-checking every connector. One loose pin here and the system won't even boot. And then a problem. As I'm wiring up power to the 5090, I noticed two of the pins on the connector look like they're completely missing. I stopped. Was this brand new card defective? So I did the obvious thing for a build like this. I asked my AI. It told me those two pins are just signal pins. Completely normal, totally safe. I trusted it and I plugged it in. With that sorted, the 5090 finally slides into the slot. This is the exact moment the whole build has been leading up to. One last pass on the cables, zip tying everything down for clean airflow. We are almost there. And here it is, the finished machine. My old Ryzen 9700X and its 64 gigs of memory, now wrapped around a brand new RTX 5090 and that 1500 watt Corsair. This is the muscle of the whole operation. Moment of truth. I hit the switch, the fans spin up, the lights come on, and it posts on the very first try. It's alive. But raw muscle isn't enough. The really big models, like a 200 billion parameter vision model, need a different kind of machine. So I'm building a second one, the brain, and it starts with this, an Intel Core Ultra 5. This is a completely different platform from the first build, Intel instead of AMD, chosen specifically for how well it handles a huge amount of memory. It goes onto an Asus B860 board with plenty of PCIe lanes, because this machine is going to run not one, but two graphics cards at the same time. And here's the secret weapon: 128 gigabytes of RAM. That much memory is exactly what lets this little box hold an enormous AI model that would never fit on a graphics card alone. Processor into the socket, lining up the pins and locking it down. There is no room for mistakes on this step. Then all that memory clicks into the slots, bank by bank, and the board is finally ready to go into the case. And now the graphics. This machine doesn't get one GPU, it gets two working side by side to give it enough power for the heaviest AI work. Here are the two cards that drive the brain. An RTX 5070 Ti paired with an RTX 5070. Together they let this machine run a massive language and vision model entirely on its own. Board mounted, cards installed, and the second machine is complete. This is the brain. It quietly runs the single biggest AI model in the entire house. So that's two machines built, but the hardware is only half the story. A server is only as good as what it actually runs, so let me show you the dashboard I built to manage all of it. This board tracks every AI project running across my machines. Right now there are over 40 of them. Video generators, voice cloning, local language models, image tools, automation bots, and every single one of them runs locally. No cloud, no APIs, no subscriptions. Each card here is a real working tool. Some build entire videos end to end, some clone voices, and some are vision models that read images, like the very models that watched all of this footage to help me cut this video together. But these projects don't run in isolation. This is the relationship map, and it shows how the work actually flows across the cluster, machine by machine. On the left is the workstation, my main box. Next to it, Ultra 5, the render and AI node. Then the three smaller machines. The arrows show which project depends on which tool, on which machine. You can see almost everything points back to a couple of shared services, the render engine and the voice tools, all hosted on the two big machines. That's the whole point of a cluster. Build a tool once and let every project use it. Now the machines themselves, all 5 are wired together on their own private gigabit network, shown here as this pentagon. Low latency, zero packet loss, completely separate from the internet. This second diagram shows which machine borrows services from which. The workstation runs the AI models. Ultra 5 handles rendering and transcription, while the smaller boxes share storage and keep everything monitored. And down here is the live health of every node, processor, memory, and disk usage on all 5 machines at once. If anything starts struggling, I can see it instantly. Finally, the power dashboard. This is the entire cluster in real time, 5 machines, and exactly how much electricity each one is drawing right now. It tracks the watts and the kilowatt hours the whole cluster is pulling, day by day, and even the cost in dollars. Running AI at home is not free, so I keep a very close eye on the bill. And right here at the top is that new RTX 5090 machine, pulling the most power because it's doing the most work. From a gaming PC to a real local AI cluster, built in about a month with a little help from the AI itself. Thanks for watching. And that's how I turned 2 machines into my very own local AI lab. If you want to follow the journey, I'll be testing more local AI models and building workflows that solve real everyday problems, all at the lowest cost possible. Subscribe to Solo AI Lab, and I'll see you in the next build.